Welcome to the 16th lecture. We have seen scattering parameters, we have seen relationship with Z parameters particularly. Today we will see the relationship of S parameter with ABCD parameter or transmission parameters. As you know that in a complex network, we divide the network into several parts. So, each sub block we characterize by S parameters. Now, while connecting, instead of connecting them in cascade in terms of S parameter, if we know the ABCD parameter, we can connect them better, because ABCD parameters or transmission parameters are designed for cascading of various sub blocks of a network. Now, as you know that ABCD parameter is depends on total voltage and current at ports, whereas scattering parameters they reflect the true wave nature of the voltage and current waves. So, if we convert from scattering parameter to ABCD parameter, then we can find for each block first the scattering parameter, then we can convert to ABCD parameter, then find the overall network's ABCD parameter by cascading those sub blocks, and then we can reconvert back from ABCD parameter to S parameter. So, that the overall S parameter of the whole network will be able to find. So, that is why this relationship between S parameter and transmission parameters one should know, one microwave engineer should know, and that is why we start our discussion. Now, first let us find the transmission parameter of a lossless transmission line. You are given a simple transmission line, find the ABCD parameter. Now, obviously, this is the moment we say transmission line. Transmission line means there it will be the wave nature that will come into play. So, we will have to find the incident voltage wave, incident current wave, reflected voltage wave, etc. Find the S parameters, and also we can find the ABCD parameters, and from ABCD we can convert back to scattering parameters. So, this strategy will follow. So, you see we have a piece of transmission line of length L. Characteristic impedance of the transmission line is Z naught, phase constant is beta, that means we are assuming lossless transmission line. So, propagation constant gamma that does not have any real part, it has the imaginary part J b, that is why the phase constant is only shown. Now, we are considering one port, there are two ports. So, on the left side you have port 1, on the right side you have port 2. So, let us find its ABCD parameter. Now, for that we need to break the voltage wave V 1, the total voltage V 1 that should be broken into the incident voltage wave and reflected voltage wave. So, V 1 is equal to V 1 plus V 1 minus. Also, the total port current I 1 that should be broken into the incident current wave I 1 plus and incident reflected current wave I 1 minus, and you know that their relationship is I 1 plus minus I 1 minus, I 1 is equal to, and that we can again relate to the voltage waves by bringing the impedance, reference impedance at port 1, let us say that is Z naught 1. In most of the cases this Z naught 1 is taken as Z naught of the transmission line. Similarly, you can do it at the port 2, that you can write the total voltage V 2 in terms of V 2 plus and V 2 minus. You can also write I 2 in terms of I 2 plus and I 2 minus. Here one point I want to mention that in a transmission matrix ABCD parameters, when we find, generally the port current I 2 is taken as it is going out from port 2, because in a cascade that helps. Now, in other two port parameters Z, Y, etc., there the I 2 flows into the second port, but in transmission parameter it goes out. That is why we have shown it as I2, but when we are writing the I2 plus and I2 minus, I2 plus is inside the port, I2 minus is out of the port. That is why I2 plus minus I2 minus, that direction is minus I2. Note this, because this is one point of confusion generally people have, that now this I2 plus and I2 minus, they can related to V2 plus and V2 minus with the help of the second port characteristic impedance Z0 2. Again, most of the cases Z0 2 is assumed to be Z0, the transmission lines characteristic impedance. Now, so you know that this is your earlier knowledge, that ABCD parameters are defined as the port 1 quantities, port 1 voltage and current V1 and I1 total, that is related to V2 and I2. Again, note that minus I2 because of the change direction of I2 for ABCD parameters, but in terms of our usual I2 which goes into the port 2, that minus has been introduced. So, this is the definition. Now, to find in A and C, you see in both these cases we require I2 should be made equal to 0. Now, I2, that means if we made in the port 2 I2 is equal to 0 means it is an open circuit. So, we will have to make that port condition, port 2 should be open circuited, and then the ratio of V1 by V2 will give us A and ratio of I1 by V2 will give us C. So, let us see that we have made open circuit, port 2 is open circuit, I2 is equal to 0. Now, in an open circuit you know what happens to the, what is the relation between the reflected voltage and the incident voltage. So, in an open circuit the reflection coefficient is plus 1. So, V2 minus by V2 plus, then you will be plus 1, then V2, and you know that V2 minus, what is V2 minus? This is this wave. How that wave came? This V1 plus wave has transmitted through this transmission line by a distance L. So, V2 minus is related to V1 plus by this relation, this propagation relation, that e to the power minus j beta L, because any wave when it moves by a distance L, it acquires an added phase of minus j beta L. So, that is why this second relation. Similarly, the V2 plus that is falling here on port 2, that is travelling through this transmission line by again a distance of L, and that is coming out as V1 minus. That is why we are writing V1 minus is equal to V2 plus e to the power minus j beta L. Now, with these three relations you can solve for these quantities V1 plus, V1 minus, V2 plus, V1, V2 minus. So, that is done. Determination of A. So, A is V1 by V2 when I2 is equal to 0, that means that condition. So, simply you can V1 you can write as V1 plus plus V1 minus, and V2 also V2 plus plus V2 minus. Then you put those equations from equation 2 and 3, and the first equation which was open circuited condition, that shows that V2 minus and V2 plus both are equal. So, we are calling it 2 V2 plus. Then this V2 minus will also be replaced by V2 plus. So, all V2 plus they get cancelled, you get e to the power j beta L plus e to the power minus j beta L by 2, which you know is cos beta L. So, A's value is becoming cos beta L. So, for a pure lossless transmission line, the A parameter is cos beta L. Now, also you can determine C. C is I1 by V2. I1 we have already said V1 plus minus V1 minus by Z0, and V2 as it is V2 plus plus V2 minus. Again you do manipulation, you see that it comes out to be J Y naught. Y naught is nothing but 1 by Z0, the characteristic admittance of the transmission line, into in this case sin beta L. So, this is an imaginary quantity. A was pure real, C is imaginary. Then you need to determine B and D. The condition for B and D determination will come if we short circuit port 1. That means, they require that V 1 should be equal to 0, not V 2 is equal to 0. Port 2 is short circuit. So, you know that V 2 minus by V 2 plus is minus 1 for a short circuit. The reflection coefficient is minus 1. So, V 2 minus by V 2 plus is shorted, and you can find out that V 2 minus, again the propagation condition, that V 2 minus that has come because of V 1 plus with this transmission. So, that is given by e to the power minus j beta L. Similarly, V 1 minus, which is coming out here due to V 2 plus, that is again e to the power minus j beta L. So, again from these 3 equations you can solve for those V 2 plus and V 2 minus. So, first solve for B. B parameter is V 1 minus I 2 when V 2 is equal to 0. So, that if you put those values, you get j z naught sin beta L, again an imaginary quantity, and determination of D, that is ratio of 2 currents, this. So, that will give you this D is equal to cos beta L, and again a real quantity. So, finally, you get the transmission parameters of a lossless transmission line to be cos beta L, j z naught sin beta L, etc. So, now this conversion of ABCD to S, this formula is there for interconversion. So, S is this is common for the whole matrix, and then these formulas. So, if we put that, then we have A, B, C, D, we have written once again here. If you do those conversion formula, you get that S parameter of the lossless transmission line is, its S11 is 0, its S22 is also 0, its S12 and S21 are e to the power minus j beta L. So, as you see that this S parameter from the S matrix, we can see it is a reciprocal network, because there are no active devices etc. is used. So, its S parameter is reciprocal. That means, if we take, or Sij is equal to Sji, we can say that, or we can also say that if we take the transition of this matrix, that will be same as this matrix. So, this is a reciprocal matrix. Also, you see this satisfies unitary property, because here if we take that this column, if we take conjugate with each, it will be just the, that means it will be e to the power minus j beta L into e to the power plus j beta L, which will be equal to 1. So, that true. Similarly, this and conjugate of this, that will be 0. So, it is a pure unitary matrix, and that is why we get that this is a lossless network. So, this is the S matrix. You remember transmission line, obviously its only transmission parameters S12 and S21, they are present. It does not have, because it is a match line, we have assumed that port 1 reference impedance is equal to Z naught, port 2 is also Z naught, that is why it is called a matched transmission line. So, for a matched transmission line, there is no reflected wave, there is no reflected wave in port 1 as well as in port 2, and we get S11 and S22, both of them are 0. So, this we got from converting from that ABCD parameter, we can get this. Now, so we can write that V minus is equal to S V plus, you can cross check the earlier result, that it will be there. Now, for let us do that, the previous formula we derived for the S parameter, that was from conversion from ABCD parameter. Now, let us see how the scattering matrix of a lossless transmission line, how we derive that. Then if these two S parameters comes to be same, we can cross check the result. So, here now we will do the same thing, find the scattering parameter by directly finding scattering parameter. We know how to do it. For scattering parameter determination, you know that if you want to determine S11 and S21, then you need to match terminate the port 2. So, you see we have match terminated. Match terminated means the termination should be an impedance whose value is equal to the characteristic impedance. So, Z0 we have connected. Under this condition, we will have to find for S11 it will be V1 minus by V1 plus, and for S21 it will be V2 minus by V1 plus. So, you see we have written that V2 just because this is Z0. So, there is no incident wave, V2 plus will be 0, and the moment V2 plus is 0, V2 plus after travelling here come out here as V1 minus. So, V1 minus also will be 0, and V2 plus we know that it is 0, V1 minus 0, and V2 minus, that means we have V1 plus. So, that after transmission will come at V2 minus, and their relationship is like a wave travelling through a length L in a transmission line, e to the power minus j beta L is the relationship. Now, let us determine S11 which is V1 minus by V1 plus. As we said that V1 minus is becoming 0 under match condition. So, S11 is becoming 0. Now, under the same condition, see what is happening to V2 minus plus V1 minus. We can put that relationship and it becomes e to the power minus j beta L. So, we have got S21. Now, for S12 and S22, we need to match terminate port 1. So, that we can find the two parameters here. The match terminating port 1 means V1 plus will be 0, V2 minus will be equal to 0, obviously because V1 plus becomes here V2 minus, that becomes 0, and who are then present? V2 plus and V1 minus, their interrelationship is like e to the power minus j beta L. So, now we can determine S12. So, we put the values of V1 minus and V2 plus, and that becomes e to the power minus j beta L. Similarly, S22 is V2 minus is 0, because this is 0, V2 plus exists, that is why 0 by a some value, that is 0. So, S22 is also 0. So, we get the same thing that we got from conversion from ABCD parameter, that shows that our formula is correct. So, now you know that if you have any circuit, if it is a distributed circuit, it is better to find its S parameter, because actual transmission is happening through waves. So, you can find S parameter, then S to Z you can reconvert back. That formula is given here, that if you know S parameter, how to find ABCD parameter, you can find this. So, we have done this, and if you apply these formulas you will have to note, actually these are available. So, you can always refer to that in your professional life and find out. Then if you find, you get back the same ABCD parameter that we got. So, now you know the interconnection between the ABCD parameter and transmission parameter. That was this lecture. So, this completes that we know now Z parameter you can convert, through Z parameter you can convert to Y parameter, etc. So, that was one journey. Another journey is S to ABCD and ABCD to S. So, now you can measure S parameter by network analyzer, and from that you can find out, as the case may be. Suppose you are one sub block, let us say one filter, you have found its S parameter. Now, you want to, that filter will be connected to some receiver or some transmitter circuit. So, there will be other blocks. Now, for all the blocks, if you find S parameter, then from each you can find ABCD parameter. Let us say there are being added in cascade. So, a filter, an amplifier, all they are in cascade. So, you know each one's S parameter, you can convert each one's S parameter to its ABCD parameter, then you can find out overall S parameter of the whole cascaded network, and then again you can come back to S parameter if that is required, or if ABCD parameter is sufficient, you stay there. So, by this the second tool S parameter, you have seen that how microwave engineers they use scattering parameter to characterize network. Now, in the next lecture we will see another two very important devices, microwave device, passive device, that S parameter we will see that how S parameter helps to understand what those devices do. That is the next 17th lecture, there you will see. Okay, thank you.